Welcome back. So, in today's video lecture, we will be looking at the demonstration of force tensiometer. Uh, so, uh, so far we have been discussing about various measurement techniques. In today's lecture, we will look at the working principle and the demonstration part of the force tensiometer. So, but this particular lecture will be divided into two. First, I will be giving you the overview of the device, right? After that, one of my PhD students will be taking you to the tour of the laboratory, the research laboratory, wherein he can show you the demonstration of the force tensiometer, right? Right. So first, let me explain, and so try to give you the overview of the force tensiometer. Let's begin. Yeah. So force tensiometer is one of the devices used to measure the interfacial tension of liquids, right? If you want to measure the let's say interfacial tension of various various fluids, you will need a device like force tensiometer. If you can remember, we have looked at the various measurement techniques like using the pendant drop method, right? Also, one can measure the surface tension or interfacial tension. So there is a device called optical tensiometer. What we are looking at today is force tensiometer, whereas in the optical tensiometer, or also known as goniometer, you will be able to use the pendant drop technique to measure the interfacial tension. So using the image analysis, we will see the force tensiometer. So it has got several components in it. So weighing balance, measurement ring or plate. So force tensiometer uses Dulloy ring method as well as Wilhelmy plate method. Often these two methods are used whenever you want to measure the interfacial tension of various liquids. Okay. So it consists of three important key components with it. So you can say weighing balance and measurement ring or plate and the dispenser, right? So using the force tensiometer, you will be able to perform several measurements, right? So you can measure the surface tension or interfacial tension, the contact angle of powder samples. So sometime if you want to measure the three-phase contact angle of powder samples using the Washburn equation, you can perform this analysis using force tensiometer, and you can also perform sedimentation rate analysis using this device. And also, last but not least, is the critical micelle concentration of any given surfactant can be determined using the force tensiometer. So this particular aspect, we will be covering this critical micellar concentration in the module 3, right? We'll look at more in details when we deal with the module 3. So how it works, we have already seen the working principle of Wilhelmy plate method. So basically you have a plate or ring, okay? You will place this plate or ring at the water surface or the liquid, your interest, which is of your interest. And the moment this plate is, brought down at the liquid surface, when it just touches the liquid surface, because of the affinity between the liquid and the plate or the ring, there will be meniscus, right? So, because the meniscus, the weight of the meniscus will act on the plate or ring, and that can be directly measured using the weighing balance. One can one can calculate the surface tension by knowing the the weight of liquid acting on the plate or the ring, right? So that's why you can measure the surface tension and you can calculate the surface tension of a given liquid. There are some advantages. So these techniques, force method is a straightforward method, unlike the optical tensiometer, wherein there can be one can make errors because it has to do with the imaging, right? So when you do the imaging and when you do the averaging, maybe we can generate errors, right? When we deal with in a device like optical tensiometer, whereas in the force tensiometer, this technique is simple and straightforward because it is based on the force balance. The measurement that we get is quite accurate. Okay, but there are some limitations. You have to be wary of the cleaning and calibration always. Okay, that is the key, right? In the if you want to get a result, right? With good accuracy, you have to deal with this thing, cleaning and calibration, right? And the other limitation is the surface condition. So surface should not deteriorate over time. So one has to always monitor the condition of the surface, right? So these two, the Villeneuve plate method and Dunah ring method, we have the schematic of these two methods is shown here, right? So as you know, the working principle of these two methods are similar. What is different is the geometry. The Villeneuve plate method uses the rectangular plate. Okay, the geometry is different from the Dunah ring. Okay, whereas Dunah ring uses the ring type device that will, to measure the surface tension. So what will be different is the perimeter, the wetted perimeter that we will be that comes along with the geometry will be different. Okay. In the case of the Villeneuve plate method, the wetted parameter will be simply 2 into W plus D, which means that W is width and D is thickness here. Whereas in the case of the Dunah ring, it is going to be 2 pi Ri plus. So you have got outer radius as well as inner radius. So what makes a difference is the perimeter, right? Okay. Because we use quite often the platinum metal or the metal alloy, a special metal alloy, to deal with the theta, right, the contact angle, because contact angle is also a variable. So when we use the platinum or the special alloyed metal, the theta that it establishes with the water is usually 0. Okay, not only water, with most liquids, organic liquids, it is negligibly small. So one can actually get away with this cos theta component, so which is cos 0 in this case will be 1. So what you need to worry about is the perimeter always, right? So that is exactly you have to do. Sometimes the Dunah ring uses the correction factor. If the ring that is employed is too finite, right, then one would have to use the correction factor. So that is that could be one of the disadvantages in the case of the Dunah ring. Otherwise, both methods are complementary. Both can complement each other. Both methods are widely used. Okay, so depending on the sample volume, and if you want to perform dynamic measurements quickly, then one can use the Dunah ring, right? And if your sample, if you got if your sample volume is too small, then you may have to use Dunah ring, right? So depending on the requirement, one can choose the geometry appropriately. Now we will move on to the demonstration part. I will stop here. The demonstration of the equipment will be shown by one of my PhD students. Thank you. Yeah.
Welcome back. Let's see the demonstration of flow tensiometer. So I'm using this system made up of violin and the model is attention. Here, as you can see in the system, we have two dispensers. One is this one and this one. That can be used for the CNC measurement of the sample attached with the needle. One will take the sample and one will take out the sample. This is special vessel where we have to kilobar samples. Or you can use another type of small vessels that can go inside, or you have to fill your sample air in this present vessel directly. This vessel is connected to the thermostat that will manage the temperature using the bath system. Also, you can see here, this is the balance where you have to hang your plate, your ring type plate or whatever type of plate you want to use. To use that, you have to hang it very carefully. Also, if someone wants to move the stage or the sample stage, it can be moved using these switches. Or as you can see here, our stage is moving upward. Now it is moving downward. This movement is used to adjust the interface of the ring type plate, Wilmer plate or whatever you want to use. Also, you can switch off or on the system during the experiment. And now I will show you the measurement of surface tension of an air water system using a Wilmer plate and a ring type plate. First, let me show you the Wilmer plate and the ring type plates. Look how it looks like. Now, this is our Wilmer plate made up of platinum. As you can see here, we have a separate cleaning procedure for this that I'll explain later. We can hang this Wilmer plate like this. Okay. Now let me show you the Denoy ring, or also known as ring type plate. This is our ring type plate, as you can see here. This is the Denoy ring plate used for the measurement geometry. You can see it has a perfect ring shape. This one is also made up of platinum material. It will hang in the system for measuring surface and interfacial tension with the CNC and other parameters. This is our sample vessel. As I told you, one can use this vessel directly, which is available in the instrument. If you want to change the temperature or maintain specific condition, you can use this vessel too. However, cleaning can sometimes be challenging. For easy handling, you can use 50 ml or 100 ml sample vial, which can be placed inside the system like this. Both volumes are available for use. Now let us move towards the software interface. This is our software window. The software is named One Attention. After opening, you will find several applications. For instance, one can measure adhesion force using a hook type needle, contact angle using a plate type needle, and a density measurement using a board. These are separate geometries for surface tension and interfacial tension measurement. You can use the Denoy ring or Wilmer plate for these measurements. Additionally, you can determine CMC using any of these two plates. Sedimentation measurement can also be performed depending on the application. Today, I will demonstrate you about the surface and interfacial tension measurement using the Denoy ring. Upon selecting the desired measurement in the software, a window will appear allowing you to choose the specific geometry, whether it's a ring, Wilmer plate, for surface or interfacial tension. I will use the Denoy ring for this demonstration. This interface allows you to create a recipe for the experiment. Here you can name our experiments. If you want to use autosave, enable the autosave option. If you want your experiment to be private, select the private save mode. You also need to specify the type of symmetry you are going to use here. Since I am using a Denoy ring, I will select it now. Next, the type of vessel you are going to use, as there are different versions available. I am going to use the small vessels. Additionally, choose the material you want to, such as the phase or heavy phase. 4 days demonstration, I'm using air and water, and you can select these from the directories as well. You can see here. A large number of samples are provided for both cases, and you can choose accordingly. If you want to add, you can also do that. Next, control the parameters. If you are conducting a specific test and the setting depend on the variability and type test, to perform a zero balance, you can set it automatically. The system will take care of the zero balance. Zero balance is crucial because interfacial tension or surface tension measurement, the ring or plate touches the interface. At that point, you need to ensure the zero balance is performed. Automatic surface detection can also be enabled. If you are using a system with viscosity that change with respect to temperature or operating condition, and you want continuous steering, you can select the steering here. Set the steering speed as a percentage such as 100% or customize it manually. The graph is, this is the raw graph and this one is the surface tension graph. You can choose either based on your requirement. The console provides details about the ongoing operations, and in the control section, you can perform a zero balance in the position after adjusting it near the ring or plate. The sample vessel is ready and I will now place it inside the vessel. As I mentioned earlier, I am using the denoiding. This thing must be cleaned properly. Always ensure that if you are using a plate or ring for any geometry in the force tensiometer, it is thoroughly cleaned. If the geometry is not cleaned or contain contaminations, the measurement will vary. Let's see how to do cleaning. For the cleaning procedure, first we will clean using DI water. Then we will rinse it with the ethanol for thoroughly cleaning. Cleaning is a critical step in this experiment, especially for tensiometer, whether optical tensiometer or force tensiometer. After this, you will use the butane gas or apply a flame to remove any biological contaminants. Continuous cleaning until it looks clearer. Now our system is cleaned properly and the ring is ready for the measurement. As of now, we have completed the cleaning process. Let us carefully place our ring on the balance. Remember, this step will not cause much movement in the system. Now, let's close the system. You can see here that our denoy ring is ready for the measurement. Notice the significantly difference between the denoy ring and the sample. Now we need to lift the stage up so that the ring is nearer the surface. You can observe as I move the stage, you will need to determine manually if the system is close enough to the surface. Once the position is set near the surface, it will become 0 and the balance of the denoy ring attached to the weighing system will also hit 0. This zeroing process is performed using software which you will handle shortly. Let us now move the stage closer to the surface. As you can see, we are approaching the interface. The denoy ring is at the interface and we can proceed to perform the zero balance. After positioning the stage and ensuring the balances reach 0, the mass and position values system will also become 0. The stage can be operated using the controls. The upward arrow moves the stage up while the downward arrow moves the down. We have already positioned the stage manually, so I will now perform the zero balance. As you see, the mass is almost set to 0 and the position is also set to 0. Now we are near to the interface. As I mentioned earlier, we have prepared the recipe. With the recipe ready, I will now start the measurement. Click on the measurement to begin. This process will take some time. You will notice change in the mass. You will notice change in the mass and the position values, indicating that the measurement is in process. The system will measure the surface tension of the air-water interface. Once the measurement is complete, you can proceed to the analysis section. Once the measurement is complete, open the measurement sample in the analysis mode to review your data. Here you can see the raw data displayed as a graph between the time and surface tension data per cycle, as well as the raw data in the tabulated form. You can export this data in the desired format. Additionally, software calculates the mean. This is the mean or average value for surface tension, in the standard deviation as well, and the minimum and the maximum values as well. For our measurement, the surface tension at the air-water interface is 71.354, which is good agreement with the standard 72.8. This demonstration shows how surface tension can be measured using your force tensiometer. If you wish to save the data, click on the export all and select the desired location for savings. Once the experiment is complete, we will lower the stage manually. You can also use a software to lower the stage, but I prefer doing it manually for better control. After the stage is in comb position, carefully remove the ring without causing any disturbance. Finally, follow the cleaning procedure again to ensure the step is ready for future use. Thank you for joining us.